Welcome back to Inquisitive Kids, or welcome if this is your first time at our channel. So in this lesson, we are going to be continuing our 8th grade math course with Chapter 13, all about parallelograms. So this will be a more geometrically centered topic. Today we're going to be looking at the properties of the angles of parallelograms. This is part 1 of our lesson properties of parallelograms. Part 2 will be coming up, so if you would like to be notified for that, then be sure to hit the notification bell as well as the subscribe button. Learning goals. Today we will understand the definition of parallelograms and other vocabulary words. We will also explore and master the properties of equal sides and equal sides of a parallelogram. So here's our introduction. We have multiple different scenes from real-life scenarios. So we can find parallelograms all the time. Here, 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 and even in parking lots. We can find them on staircases, Can you give any other examples? Related concepts of parallelogram sides. If you translate the two sides of a triangle separately, what shape will you get? Well, looking at our little demonstration here, we see that we can get a parallelogram. Please observe the two groups of opposite sides with the same color. What is their positional relationship? So, what is the relationship between the two red lines and the two blue sides? Observing the figures, what characteristics do the parallelogram sides have to do with their positional relationship? Well, in this shape, we have no parallel sides. In this shape, a trapezoid, we have one pair of parallel sides. And in this quadrilateral, we have two pairs of parallel sides. So quadrilaterals with two pairs of parallel sides are also called parallelograms. So here's the concept. A quadrilateral with two sets of parallel opposite sides is called a parallelogram. In geometry, it would be written as if AB is parallel to CD and AD is parallel to BC, then ABCD would be a parallelogram. This is the way you would write it down on paper, and it is read as parallelogram ABCD. The line segment formed by two non-adjacent vertices of a parallelogram is called its diagonal. For example, AC. Another example of a diagonal would be if we connected the 2 points B and D. In parallelograms, there are opposite sides and opposite angles. Angles A and C would be opposite angles, and opposite sides would be AD and BC. Let's discuss. Identify the parallelograms from the following 5 shapes. Well, in here, number 2 would be a parallelogram, so would number 5. Number 3 is not a quadrilateral, and neither is number 4. And for number 1, there is only one pair of parallel sides. So according to the definition, only 2 and 5 would be parallelograms. Central symmetry in parallelograms. As shown, two identical parallelogram pieces of papers are stacked together, and a thumbtack is stuck in their center O. By rotating the parallelogram 180 degrees around point O, what can we find? Well, if we rotate that 180 degrees around point O, we find that it overlaps perfectly. Let's look at that again. So, what predictions do you have? According to the rotation, do you now know what a parallelogram is? So here is another property of parallelograms. When parallelogram ABCD rotates 180 degrees around its center O, overlapping with itself, we know that it is centrally symmetrical. The intersection between its two diagonals, O, is its center of symmetry. A parallelogram is a centrally symmetrical figure, and the intersection of its two diagonals is its center of symmetry. Now moving on to our third chapter, sides and angles of parallelograms. Can you form a parallelogram by joining the equal sides of two congruent triangles? How many different types can you create? Well, we first need two congruent triangles. For example, this. Put together, we have a parallelogram. Another way would be this, and so is this. These are all examples with parallelograms with the same two congruent triangles. Through this puzzle, what can we conclude? We can conclude that opposite sides of a parallelogram are equal and that opposite angles are equal as well. Is this conclusion correct? Well, here is our method 1 to finding out. Measurement. We can directly measure using rulers. But is this method exactly accurate? Because what if you're off by just the slightest bit? It may look accurate, but it's not always precisely accurate. Method number 2 would be to use logic and reasoning. A diagonal of a parallelogram divides the parallelogram into two congruent triangles. So we can convert a quadrilateral into a triangle. We can do that by connecting diagonal AC, giving us two congruent triangles pieced together. So here is an example of a proof. Given parallelogram ABCD, AB is parallel to CD and AD is parallel to BC. So I want you to prove that AB is equal to CD and that BC is equal to DA. Also prove that angle B is equal to angle D and that angle BAD is equal to angle DCB. Well, here is our proof. As shown, we can connect AC, forming a diagonal. Because AD is parallel to BC, AD is parallel to CD. So angle 1 and 2 are equal, and so is angles 3 and 4. And since AC is the shared side of triangles ABC and CDA, we know that these two triangles ABC and A and CDA are congruent using the rule ASA, angle side angle. Therefore, we also know that AB is equal to CD and AD is equal to CD. So we can prove that angle B is equal to angle D. And because angle 1 is equal to angle 2 and angle 3 is equal to angle 4, we know that angle 1 plus angle 4 is equal to angle 2 plus angle 3. So angles BAD and angles DCB are the same. Think. Without adding auxiliary lines, can you directly use the definition of a parallelogram to prove that its opposite angles are equal? An auxiliary line is a line that is not given, but that you draw to help you solve a problem. Well, here is our proof. Because AB is parallel to CD, and that angle ABC plus angle BCD is equal to 180 degrees, and that AD is parallel to BC, we know that angles BAD and ABC added together is equal to 180 degrees. We also know that from this, angle BCD is equal to angle BAD. In the same sense, with the same reasons, angle ABC is also equal to angle ADC. So here is our knowledge key point. This is a good time to pause the video if you are taking notes. Here is us concluding the properties of parallelograms. Opposite sides are parallel. In its geometry, the description would be that if ABCD is a parallelogram, then AD is parallel to BC and AB is parallel to CD. Opposite sides are congruent. Since ABCD is a parallelogram, AD is equal to BC and AB is equal to DC. Opposite angles are congruent. ABCD is a parallelogram, therefore angles A and C are equal, and so is angles B and D. So this concludes and wraps up all of the main properties we have learned from this lesson. So again, this is a good time to pause and just think about what we have learned so far in this lesson. So let's do a problem. We are given parallelogram ABCD. E and F are 2 points on the diagonal AC. Also, AE is equal to CF. Prove that BE is equal to DF. Well, here's our proof. Quadrilateral ABCD is a parallelogram. Therefore, AB is equal to CD and AB is parallel to CD. Therefore, angles BAE and DCF are equivalent. And since AE is equal to CF, therefore triangles ABE and CDF are congruent using the formula SAS, side angle side. So BE is equal to DF. Let's do practice. The school bought 4 trees and planned to plant them in the garden. 3 trees have already been planted as shown. The school wants to plant these 4 trees as a parallelogram. Where do you think the 4th tree should be planted? Remember, here's a hint. There's not only one answer to this problem. Well, we could make a parallelogram by connecting a point over there. But we can also move it to this side, creating a similar parallelogram but slanted in the other way. We can also put it below, which gives another parallelogram. Class summary. Parallelograms. Its definition is a quadrilateral with 2 sets of parallel opposite sides. Symmetry. The intersection of 2 diagonals is its center of symmetry. And its properties is that opposite sides are parallel and congruent, and opposite angles are congruent. Today we understood the definition of parallelograms and other vocabulary words. We also explored and mastered the properties of equal sides and equal angles of a parallelogram. So that's it for this lesson. And if you would like to see more of Inquisitive Kids channel, don't forget to hit that subscribe button as well as the notification bell so you will be notified when we next upload. Thank you so much for watching through Inquisitive Kids, and we'll see you next time.